you to my quiet water. I restore your soul. Come rest in me.
Do you need help affording Lilly insulin? Cost savings options are available through the Lilly Diabetes Solution Center. More at lilly.com.
When the land is your livelihood, there are no shortcuts. Doing it right is plan A and plan B. Because there's no time for downtime. You need equipment that has your back, that's built to the same high standards you live by, that's up to the challenge of half-ton hay bale challenges, runaway cattle challenges, that's a lot of mulch challenges. You need the power, durability, and versatility of Kubota equipment. Built right to get every job done right. Kubota. Together we do more.
I could just sit and wait for all your goodness to feel the present. I could just stay right where I am and hope to feel something again.
Morning, guys. I think let's get started. Let me just shut up my Pandora and we'll get started soon. I think right now we have around 13 of you guys or 14 now getting on. So I'm gonna just start by saying, hi to everyone. Just quick thing, let me grab a cup of water, okay, in case that, I think I need a little more lubrication. I don't have any issue or anything. It's just my annual severe allergy. So, but I think it's good thing that maybe perhaps now we do online. Otherwise, a lot of people or some of you guys may be uncomfortable if someone sneeze or something. So again, guys, stay inside the house as much as you can, or please do so. I think as the governor has announced whatever stay home order, so only necessary things that um, whatever thing that is the must that you have to go out, but otherwise, please stay home. I think right now Louisiana has a big hit. If you monitor the number of patients, I think it crazily the number is shot up. So I think even though I think the lockdown is a very strong measurement, but I think it's a must. Okay, so but don't be panic. Just be prepared, and then do anything that makes sense. I think some common practice is just stay away from each other. Especially when you go places, if you have to, 6 feet away, and those sort of practice. So let's get started on our class. I think before we get into or continue on chapter 2, let me see whether anyone have typed something or asked me question. Yes, um, I think I forgot the raccoon bro. I think that is, I think I remember you. I think the question is that will the Moodle quiz has unlimited attempt? No, I think there should be one attempt and limit time. So I'm gonna talk about the quiz soon. Okay. So let's get started. Let me see whether this thing switch to. Good morning, everyone. Good morning again, everyone. So I think last time we stopped on Thursday, and I think we talk about OS structure as well as important feature of operating system. Okay, I think today we will continue on hi Carrick. Okay, so we today we will continue on, but before we get started, I think Carrick has asked about the quiz. I already put the quiz on Moodle, so please do the quiz before Friday midnight. But before you do so, I would like you to review lecture 1, which is the intro to OS. I already put the PowerPoint on Moodle, and if you guys have not watched or you want to watch 1 hour video before doing the quiz, I think that would be a good idea. The quiz would have one attempt, and that would have limit time for 20 minutes. There are a 5 question, okay, which is a simple question such as what is an operating system, and then this is multiple choice that you have to choose one of the answer. Okay, so if answer are somewhat similar, please choose the best one. Okay, so it's already on Moodle, and please review the material and the video before you do the quiz. It should not be that difficult. If you have reviewed the material and understand whatever the content, it should be done in 5 minutes. Okay, so it should not be a whole lot of issue there. And the main reason that I put the quiz, and I would try to put the quiz on Moodle every week or every other weeks. I mean, in this case, it would allow me to see whether you understand or you follow the material or not. And also for some of us who may have other priority things to do, I just want to encourage, that person to start, follow the class and pay attention to whatever, your responsibility. Because I think right now I know that there are a lot of challenge, but just do what you can control and do your best. And then whatever you can control or your responsibility is study. So I think, soon all these challenge gonna be under control, and then we're gonna get on our normal life soon. Okay, so again, please do the quiz before March 27, which is Friday by midnight. Okay, and then you have only one attempt. The quiz has limit time, only 20 minutes. And I think if you understand the question, it's gonna take you less than 1 minute. Okay, or otherwise, I budget that, carefully read them, 5 questions. So each question you should have 4 minutes easily. Okay. Okay. If you guys have any question, so please type and ask me on the live chat comment. All right. Okay. Let's move on. Another item that I would like to remind you is that the term presentation topic. I would like you to pick your topic by April 1st or April Fool. Otherwise, I will assign the topic for you. Okay, the topic could be anything. Okay, that related to operating system, such as, let me give you an example of the topics. Okay, as you all know that one of the main feature or service of operating system is task scheduling. Okay, don't do the normal task scheduling or CPU scheduling that we're gonna cover in chapter 5, but there are some quite interesting techniques. Okay, such as CPU scheduling that on, for example, the mobile phone. Okay, I think in that, the energy aware scheduling is quite interesting. Okay, and example, if you just click on that link, it should get you start on some of these topics. And I hope that everyone pick different topic. Maybe some big topic, there may be a few people choosing the same topic, but I suspect that the content that you're gonna present is not gonna be all the same. Okay, other aspect of, for example, CPU scheduling or task scheduling is reliability aware scheduling. And in fact, on that link, IEEE link, that is my work that me and my research group a few years ago has published quite several quite a bit work in this field. In fact, probably 10 years ago, we are one of the whatever the research group that being recognized as top group in whatever in this field. Okay, so take a look into this. Okay, also other topic I mentioned about Docker or container. Okay, if you are not familiar with Docker, make sure that you put Docker into your or register Docker in your skill. Okay, Google it. I think it's quite popular and hot in industry right now. Docker is one system that implement concept of container. Okay, which is a runtime plus OS plus virtualization. Okay, and so I hope that one of you guys would pick the topic of Docker. Another topic is virtualization tools. There are quite a bit virtualization tools in industry. Okay, and virtualization or virtual machine is very popular. Is um, very important. Tools that in industry nowadays. AI role in operating system and its future. Okay, so I think that also another good topic that I suspect a few of you guys might want to choose this. Okay, and then voice-based OS or voice user interface, such as Siri, Amazon Alexa, Google, whatever voice. Okay, embedded OS. Okay. some of you guys are interested in computer control, like type of equipment. For example, I mean in uh, airline industry, in the airplane, or whatever, the smart bomb, or robotics. Okay, OS for IoT, distributed OS, etc. So I think these are just sample topic that you can choose, and once you make decision, please send me the topic via email. Okay, let me see whether we have any other question here. Okay. All right. Okay. So let's move on. Let me just go to another screen quickly, because I just want to also see, some video or my YouTube, whether I think they're all right or not. Okay. So any question, please feel free to chat or type. Okay, on the live chat channel. All right. Okay. Now, well, let's continue on our discussion on chapter two. I think we're gonna start deep dive into an operating system design, structure, or architecture. I mean, on this screen or PowerPoint, you see that variety of things on this screen, such as your computers, the 3D printers, the car that has computer control, the refrigerator, supercomputer, whatever, the smartwatch. All these equipment or device uh, require a system program or operating system to help provide user interface and manage various resources. Okay, so with that, I mean, the system program or operating system based on whatever the environment or device that it deploy on. It's not one size fit all. Some of which may require a special feature or a special service, such as I think I mentioned before, your mobile phone or your smart device that does not have power plug in all the time. In that case, operating system, beside the normal service such as CPU scheduling, memory management, it also must provide a good power management. Okay, most modern operating system, okay, design or architecture as a ring or layer approach. That means it divide into multiple layers, from the hardware layer on the bottom, and then the hardware interface or hardware dependent kind of interface in between hardware and the next layer. Apologize for my whatever the notification on. uh, Let me just turn off my speaker or audio, so that it's not going to interrupt. Okay, so as I mentioned, most modern operating system architecture or design is layer approach. So it divides into multiple layer, and each layer has its own functionality. Okay, to communicate, it only allows layer to layer communication in a normal approach. Okay, but with this layer approach, okay, it provides a better way in terms of the design and reusability in the future, because of once if you have um, a non-layer approach, meaning that everything in one layer, in one bundle, thing change in big layer, it may impact almost every other layer, or almost every other modules. Okay, so in that case, if the module if you have layer approach, okay, the change within that layer will only impact in that layers. Okay, it would not change things on the above layer, such as application layers or system call layer or the kernel layer. If let's say that the hardware layer change. Okay, so in fact this layer approach is springboard a lot of adoption of IT technology. I mean, do you have a lot of computer or the device or smart device come out? I mean, um, very now and then, very often. And the main reason that I mean, the new device can be um, introduced so quickly because of this layer approach. I mean, the upper layer or operating system can be reused. All you need to do is just change the interface from the hardware layers. Um, so let's move on. So I think the different design, different implementation of operating system on various choice of hardware, the type of system, and the purpose of the main usage of that system. Okay, it drive the architecture, the design of operating system. Even though it appear to look like layer approach, but if you look into each layer, you can see that there are something slightly different or quite different. Okay, for example, most Windows system in the past or nowadays is used for um, the desktop or the notebook. Okay, but some OS that designed specifically for mobile, for example Android. So I think later on when I show you example of Android architecture, I will highlight a certain layer or certain module that designed specifically for specific purpose. Okay, so the way the design, the implementation of operating system is driven by the goal or how you want to use or what you want to have in as the main feature there. So in that case, I think for one who want to introduce the new device that deploy an OS, then you have to start list what are the main features, okay, or what are the goals that you want to use the device, so that you can start listing the specification or in term of later on when you take software design or software engineering, you're gonna hear the technical term called requirement, which is a feature in which the user want to acquire or want to have. Okay, so with that, when we start implement the operating system or design operating system before we implement, we must define goals. And a lot of time you have user goal versus system goal, because the user, I mean the end user, may have different objective than the system owner. Okay, so for example, let's take a look at user goal. A user goal in a way that they want to have operating system that must be convenient to use, easy to learn, reliable, safe, and fast. However, the system goal operating system should be easy to design, implement, maintain, as well as flexible, error-free, and efficient, and maybe perhaps promote or maximize utilization of the system. But some of user goal and system goal may go opposite. For example, the user may want to use the system very easy, quick, and responsive. However, the system goal or the system owner that I mean provide to system goal, they may want to maximize their investment or optimize or maximize the system uses. And then that if you want to maximize system uses, that means the resources gonna be shared among various users. So in the sense, in that case, sometimes user goal may be opposite to system goal. However, the whatever the company or the people who responsible on operating system design or implementation may have to come up with a compromise solution, in between user goal and system goal, if they're not go hand in hand together. Okay, so let me move forward. Okay, I just take a look at the question. I don't see any question. So let me give you example. As I told you, most operating system has or modern operating system has layer architecture, as you see from this example of Android. You have bottom layer, which is Linux kernel. In fact, I have shown you within Linux kernel there are some layer within that layers. Okay, but then on the top of in this Android, on the top of Linux kernel, Also, Android enhanced with the libraries that support certain type of services or feature that they want to achieve. Okay, but the most distinct, as you may know, that Android originally designed for mobile phone. Okay, from in fact before Google bought the company that introduced Android. I think there's another company who create Android. You can Google and then look into more detail. The thing that I like to highlight on this, I think this version I probably forgot to save, but let me just uh, trying to get my pen. I just want to highlight here. The most distinct feature on Android beside a generic operating system is the phone service, okay, on the top. So I think I don't expect you to remember all these detail, but I think the main idea that I want to communicate is layer approach, but also since certain system is target for certain use, for example, for telephone type of service or usage. So therefore, Android also include phone module or layers. Okay. Um, Now, uh, next is Chrome OS. As you all know that Chrome OS is deployed on whatever the Chromium or Chrome machine, okay, which basically the main purpose is web app or web services. So therefore, you can see that on the bottom, and again, this is layer approach, okay, where you see you have hardware, you have customized firmware, and then between customized firmware, which is that is hardware specific, you have Linux kernel interface in between, and within Linux kernel, which later on we're gonna see or blow up this Linux kernel, you're gonna see within there are multiple subsystem or layer within Linux kernel, and on the top it got X graphic libraries, which is basically X graphic library is provide Windows, I mean, multiple window, mouse and click and all those kind of things. And then the most distinct from Chrome OS from other operating system is also provide Chromium as well as the web type of services. Okay, so I think again you can see that specific need from this Chrome OS is more toward web application. Now the next uh, example of OS is Fire OS, which is um, it has some version, but I mean compare popularity from Fire OS among others. It's not quite popular. Again, this could be a case study that you can see is layer approach and then has different modules here and there. So don't get hung up on the detail. I mean, for the kick, you can start looking to, I mean, what how they are kind of structure and see different modules. Okay. Um, well, I think Carrie will talk about some change, but I will update the PowerPoint or the latest version. Once I complete, I will replace the existing one, because every time before I'm coming to this live broadcasting, I review, spend time review the PowerPoint again, and sometimes I add here and there. So I think for someone, I just want to read a comment that Carrie has asked. I think he noticed that there's some change in terms of the order of the slides here. Use whatever I have that I post originally as the guideline, but eventually once I complete that chapter or lecture, I will update with the latest one. Thanks for asking. Okay. Now continue on operating system design and implementation. Before you start, as I told you, you have to know, or you have to know what the user need, or what is the target usage of such system. Okay, if there's gonna be smartwatch, you know that people gonna wear, and then they're not gonna be any power plug in. So therefore, I think you need to start defining the requirement or the policy. which is the policy is what to be done. Okay, and then from the policy it will drive the design, and then you have eventually an architecture. And you can think about what is architecture. Architecture is just like a diagram or a blueprint that represent the design of your system. And then from the design, from the blueprint, then you're gonna start building or implement the system. So in that case, we call mechanism or implementation is how it to be done. Okay, how to do it. So normally, when you start do some development, okay, or writing some app in industry, you should separate these two process or two whatever activity, not trying to kind of mix them together. Okay, by first discuss what are the important thing, what are the needs, okay, that the user want to use or the end user want to use, that we call policy. And then from the what part, then you drive toward the how part. Okay, how do we implement such thing? For example, if you think about an application that you want to do for e-commerce, so in that case, you have to start listing, the policy. In fact, the policy of the e-commerce is, you have to have people register and log in. So in that case, the policy is that we shall have an ability to allow user to add themselves into the system. And then the policy in which you may want to put forth that once you have that user logging in, then you register, then the user must uh, authenticate themselves. So you have to have a username and password. So those are the policy or what to be done, okay, or the requirement. Now how to implement those? Then the designer, the developer, or the people who write code later on gonna have to start thinking that how do we store those user registration? Should we store in database or flat file or something? That's the hard part. Okay, same thing, same concept of this software engineering also applicable to operating system. Okay, so you have to design or come up with policy that would drive, the design and then eventually the implementation, which is how to do something. Okay, policy will decide what to be done. I hope you get some of this idea, but I think later on the same concept, okay, on the what part and the how part, the policy, the implementation, you will also study in 403 or uh, uh, the software design or software engineering. Now, let's look into a various system structure. An early operating system, which is early 80s, okay, MS-DOS, or before it become Windows, okay, has been introduced to one of the first personal computer or PC, okay. And with that, early version, it does not require you to run a multitasking or graphic user interface. So therefore, MS-DOS is written with uh, most functionality in the least space or the least capable kind of hardware. Okay, so in that case, the MS-DOS structure is quite simple, such as, if you see from this diagram on the bottom, I think I omit the hardware. The ROM or the BIOS device driver sitting on the top of the hardware. And then from the ROM BIOS, MS-DOS has its own layer of device driver, which is, I think, the main purpose of they have their own device driver or MS-DOS device driver. They want to shield any change from the underlying hardware so that the code or the functionality on the device driver that not hardware agnostic, okay, or that hardware agnostic, it could prevent, the change or the new development. And then on the top of MS-DOS device driver, it got a set of system program that in the past is called resident system program. So that are the module that manage how to execute the task, how I mean to do file management, various type of operating system services. And then on the top, it got application program that communicate through system program layer. And then eventually, if application program require for example, system resources for accessing. I think during the time that MS-DOS introduced, there's no USB port or anything. If you want to communicate through your mouse or whatever the external communication, you have to use a serial RS-332 port. Okay, or if you plug in the printer to your personal computer, there's no USB device. You have to plug in. I think it's called parallel port. So I think you can Google and then see some of these historical aspect of early hardware and operating system. So let's move on. The point I want to show here, MS-DOS has very simple layer approach and not a whole lot of complicated architecture. Now continue on layer approach. Okay. The idea of operating system divide into a number of layers or multiple layers. From the bottom layer, which is normally called layer 0, equate to the hardware, and then layer 1, layer 2, layer 3, layer 4. So all this idea or concept on layer is just to divide the task of system program or operating system to be incremental, to be easier to develop and design. Okay, and in fact, if some of the change within one layer may not impact other layer to be changed. Okay, so I think that is one of the main idea, and being I mean, the layer approach is not new. It's being introduced in the past 30 years, still very solid, very classic architecture nowadays. Even though some newer operating system code, whatever that is as modularity, but in fact modularity and layer, it just look very similar hand in hand. All right, okay. So I think this diagram showing layer approach where layer 0 is represent hardware, and then layer 1 maybe represent hardware interface, layer 2 is kernel, layer 3 is system core, and then the above layer is application layer. But anyhow, if you just cut the layer and then unfold it, the layer just look all this ring approach just look like layer approach. Okay, so link and layer, I think it can be used, the term can be used interchangeably. Okay, now one of the very first operating system that implement layer approach is Unix or Linux, or later on is Linux. Okay, originally the system that run Unix or Linux has very limited hardware functionality because it's being introduced like 30 plus something years ago. As you can imagine that you don't have gigabyte of memory, you probably luckily that you would have like megabyte or a few a thousand byte, or not a whole lot of the hardware capability. So therefore, original Unix operating system is very limited in terms of structure. In fact, the original system or Linux system separate the kernel or the operating system into two parts. Okay, the first part is a set of system program, such as all normal system program command that you use, pwd, change mode, ls, mkdir, or such. Okay, so those system program provide system services for end user to access system resource. Okay, such as if you want to store the file, system resource would be file storage or file management. Okay. Also, another big part of operating system is we call kernel, or a main program that run all the time. Okay, It consists of everything below the system call interface that include such as the subsystems such as CPU scheduling, file management, memory management, and many other operating system functionality. So let's take a look at the diagram. It's probably would look more clearer here. Okay, so as you see that you might have seen a slightly different diagram. This is one perspective of Linux or Unix system structure. As you see, if you see from opposite end, and also as you know that operating system is a system or system program that provide user and hardware interface, okay, or user interface. So you can see that opposite end, that on the top you have user, and on the bottom you have devices or the hardware. Okay, now let's take a look from the bottom up. So from the bottom, if you want to break down the hardware, you may see the hardware such as memory controller, physical memory, CPU, disk controller. In the past, they have also the tape drive and all those. Um, Beside that, early version of operating system, I mean, you don't, I mean, it's run on the server. So in that case, it required the login, and the login, imagine that you don't have these Windows or Mac or whatever Linux that you can pop up window. You have physical terminal, just like the old television, the tube television, that you have keyboard. Okay, and then from each of those terminal there is connection, okay, to terminal controller that normally in the past it connect via a port called a serial port RS332. Okay, so and then once you start typing or hit one of the keyboard, you wake up whatever the terminal, and then start sending some signal via that hardwire or the interface line. Okay, and then it's gonna pop up the login and the password, just like the regular terminal that you use nowadays. Now, going on the top of hardware layer, you can see that the whole big band of kernel, which is, as I told you, is one of the big part of Linux operating system. Okay, which is the core operating system part. Okay, that consists of various subsystem. Okay, within that kernel, you have kernel interface to hardware. So in this case, any hardware change, okay, the file system implementation, CPU scheduling, or page replacement, or those various services would not change. Okay, all you need to do is just change the interface, the API to the hardware layer. So that's what I'm trying to highlight, that this layer approach, okay, it prevent change from underlying layer. So in this case, if the new hardware come out, all you have to do is just replace underneath hardware, and then check or validate the interface to the hardware. If the interface to the hardware, which you have newer version or faster hardware, remain the same, then you can just compile and test it again. Or otherwise, if there's some change, then just change at the kernel interface to the hardware layers. On the top, it still remain the same. So that's why Linux or Unix become very popular and then being adopted later on into a modern operating system. So if I just read you quickly on the kernel feature functionality in kernel levels, okay, you have CPU scheduling, page replacement, demand paging, virtual memory, all those we're gonna discuss in later chapter. For example, CPU scheduling is chapter 5. Page replacement and memory paging, I believe that is a part of memory management, including virtual memory, that I combine chapter 8 and chapter 9. File system and IO, all those which is in the middle of the kernel, that is chapter I believe chapter 11. Okay, so anyhow, continue on. Now, for these kernel services or operating system service, in order to provide this feature to the user, then it provides system call interface to the kernel. So user may not directly use the kernel okay, but then they may use application that make use of this system called interface. So therefore user will run their application on the top layers, and using shell, as you see that the shell is the program that enable user interface in terms of command line. But nowadays beside the shell you also have graphic user interface that wrap around all these command or the shell command and allow user to access underlying system services. Okay, so I think if you follow me, you can see that I think this layer approach it quite I think very useful, and it prevent, it make the development of operating system easier and more software engineering kind of aspect. You can incrementally add more modules or more functionality, and then chill the change with those layer kind of interface. Okay, if you guys have any question, please feel free to type. Just stare at the question. There's no question there, so let's move on. Now, if we take a look at Windows system, okay, I think I have shown you this. As you see on the bottom layer, I mean, it probably if you look, it's very small print there. It's called hardware abstraction layers, which is sitting on the top of the hardware. So in fact, that layer is hardware to kernel interface. Okay, and then you have kernel that's sitting on the top. If you take a look at the left bottom kind of box there, okay, you see that the light purple band there. You see that there's a hardware abstraction layer and kernel that's sitting on the top, and then on the top of kernel you have various operating system services. So in this case, Microsoft kind of separate out certain system service out of the kernel. There are some um, benefit of this. I think later on we're going to discuss this concept we call microkernel. So don't worry to remember all these detail. I think my point to show you this is I just want to show you the layer approach, the modules, and add-on enhancement of certain kind of feature that is separate out from the kernel or specially add into this system. Now coming to microkernel structure, I think it's a concept. There are some implementation of microkernel, such as in MACH, okay, which is the system that originally introduced by Carnegie Mellon University, in Pittsburgh, Pennsylvania. I think they got DARPA or the defense kind of funding to work on this many years ago. I believe more than 20 or 30 years ago. Okay, so the concept of microkernel system structure is move as much as features or functionality out of kernel to the user space. Okay, the main reason or the main benefit is as follow. I'm gonna talk about it, but and then I mean enable the communication that take place between user modules and kernel module via message passing. And the main reason that moving as much the kernel feature out to into user space is to make the kernel is smaller, so it easier to extend microkernel instead of every time we have to go change the kernel. Then we can go change in user space, but then we have to have a specific kind of protection mechanism on the feature that we move outside the user space. Other benefit is easier to port operating system to new architecture because the microkernel becomes smaller, so therefore it's easier to port to the new hardware. And it's more reliable because it's less code to be running in the kernel and more secure. But the issue that may impose is as I mentioned on the second bullet list, it requires a message passing communication. So therefore, you may also get hit by performance overhead from user to kernel space communication. But I mean, with the current hardware, the bus design that much that very fast. If you don't excessively, I mean, try to do communication, too much communication, so therefore the benefit that you gain will make this whatever the disadvantage kind of disappear. Okay, so I think it's all depend on the analysis, the design, and the engineering. All this you can calculate because I mean, if you can, if you understand how not only operating system but your application, how do they work, how do they interact, you can come up with the performance model that you can predict, what kind of performance that you're gonna get hit or you're gonna get uh, you're getting into. Okay, from the design one, design two, because when you start designing any system or come up with the solution, you must have a alternative solution to compare. What if I use this but not using this? What is the consequence? What are the reliability aspect? What are the security, issue? Are there any security issue? What are the performance hit? All those kind of things. Okay, all these aspects, I mean, in terms of software design or system design, when I teach 403 or software design, I think I touch upon some of these aspects. um, but I think I hope that when you get into those classes, you're gonna start understand this more and more. um, Example of I mean, this diagram showing Mac OS Mac OS X structure, which is, it may not be the latest but is one of the early version of Mac OS. In fact, if you see Mark MACH on the bottom, that you have whatever those blocks, in fact that is a microkernel. Okay, and BSD also one of Unix distribution, stand for Berkeley System Distribution, which originally developed by UC Berkeley. Okay, so a lot of this operating system has been researched and developed by, I mean, some big universities such as MIT. I mean, if you look back into the chart of historical aspect of OS, and you see one of the first operating system called Multics. Okay, Multics is an OS that under collaboration between MIT and AT&T or Bell Labs, which is the company before I worked for before I moved to Louisiana Tech. BSD, also another operating system researched originally by the UC Berkeley. Okay, and then marked on the bottom of this Mac OS, which is microkernel, also is a result from research from Carnegie Mellon U. Okay, so let's move on. Now there's another concept called modules. Okay, which is talk about in Solaris, which is Sun Microsystem. I'm not sure you guys are aware of Sun Microsystem. In fact, Sun Microsystem is a company, or the founder of this company who invent Java. Okay, there are three guys, Bill Joy and two other guys that I don't remember their name. Okay, they are the one who introduced Java into the world. Okay, so 20 or 30 plus years ago, Sun Microsystem is one of the top computer company in the world. Okay, but I think things change. Right now, there's no longer Sun Microsystem. Oracle, which is database company, bought Sun, and in fact, they bought Sun, but they don't continue market whatever the hardware. I think they still keep pushing on database, which is the main application. But in terms of modules, okay, which is similar to a subsystem or those layer approach. Okay, most modern operating system implement kernel modules. Okay, which has adopt the concept of object-oriented approach, use component-based kind of architecture, and then, define a well-defined API or interface so that each module can communicate to the others. Okay, and then this module can be loadable to the kernel without bring down the kernel, except if you have main kernel functionality that you need to upgrade. Sometimes you cannot avoid to bring the system down, but mostly since you separate many system services as the modules are outside the main kernel, so therefore all these modular approach, it I think you could define the well-defined interface, and then the functionality how to use each feature may be adopt the object-oriented approach. Okay, so the diagram on Solaris, which is Sun Microsystem modular approach, is showing on this diagram where you have the core Solaris kernel, okay, that has interface to various modules, including scheduling class, file system, loadable system, core executable, exec, executable format, a stream module, device driver, and miscellaneous modules. Okay, but all in all, I think if you kind of check, this modular approach, then you can transform this into layer approach as well. So I see that layer or modular approach, okay, or subsystem component based, okay, they all has some similar nature in terms of architecture, which depending on or heavily depending on well-defined interface or API. All right, so let me see anyone has any question. All right, okay, let's move on. Let me take a look at quick to see um, someone type any question there. All right, so now my initial thought on this virtualization, I thought that if I have time, I'm gonna spend one complete lecture on virtualization, because virtualization become increasingly important, especially in computer industry. Okay, so not knowing virtualization or concept of virtualization or virtual machine, I think it would handicap your ability to communicate or work in industry. Okay, so but I'm not sure we have enough time on virtualization as one lecture, so therefore I'm gonna walk you through 6 7 slides on virtualization, so at least you get some of the idea of what is virtualization. In fact, virtualization is a technology or concept that make the complete logical bundle of hardware, operating system, and kernel into one bundle. Okay, so it's just like create a sandbox of the completely virtual system for you, so that you can deploy different OS on this, this bundle, and then different OS on another bundle that in fact running on the same hardware. Okay, but then the key enabling technology or the module that support this virtualization concept. In fact, you can think about, you have virtual machine creator called hypervisor. Another term, if you see on the bottom here, hypervisor, in fact, is you can think about hypervisor as an operating system of virtual machine that allowed the system admin to create virtual machine, and then within virtual machine you have a complete logical kind of entity of the hardware, okay, that this hypervisor manage. Okay, and then on the top of this virtual machine you can define or you can deploy operating system and set up an app as if has its own machine. Okay, so the idea or concept of virtual machine is take the layer approach to its logical conclusion. So it treats the hardware and operating system kernel into one bundle. So in this case, virtual machine provide interface identical to underlying bare hardware. In fact, you may have one CPU, but this virtual machine concept can create multiple CPU. And in a way that underlying layer, those hypervisor will help manage and schedule the usage of CPU through those layers. So virtualization give you an illusion of multiple machine, complete hardware and OS. And nowadays they take virtualization into the next level where not only you can virtualize the machine, you can virtualize network, you can virtualize the storage, you can almost virtualize anything, like those switch, those the router, the load balancer. So operating system create illusion of multiple processes, but then hypervisor or virtualization create a illusion of multiple machine for you. Okay, so you have to make distinction between OS that create an illusion of multiple processes or the task, because once you start execute some application, then you have a process that is the placeholder to run your application. So process is an abstraction or illusion of a computing unit that operating system provide to you. Okay, but then however virtualization create an illusion of the whole hardware. Okay, that you can install operating system on the top. So I think you need to make this distinction between the two. um, Now let's move on virtual machine. So I think let me complete this virtual machine kind of lecture, and then I'm gonna do a 3 to 5 minute pause as I told you. Okay, so within virtualization idea or concept, the key enabler, as I told you, called VMM or virtual machine monitor, or another term called hypervisor, as you've seen from the very first slide of this virtualization. The resources of the physical computer are shared and create toward, I think, the concept called virtual machine, that you have CPU scheduling, the spool of file system, and then the terminal or different other device that get virtualized in a way that the user would feel they have their own machine. And all this, logical entity of the virtual machine is also provide a sandbox or a secure sandbox, in a way that if that thing, if that virtual machine or the OS or app get compromised, it would not interfere to another virtual machine. Okay, so if you see this diagram on the left hand side, is a typical system that has no virtual machine. Okay, so you have hardware, you have kernel, and then you have a user sitting on the top that running various hardware there. Okay, now on the right hand side is an architecture that show how virtualization work or virtual machine work. So same thing, as you have the same hardware. Okay, but then you have VMM or hypervisor here. Okay, we another term called, we have virtual machine implementation that would allow you to spin up virtual machine that give you a logical completion of the virtual machine. Okay, that you can install the kernel on the top. um, there are slightly different architecture on virtual machine. I think there's a term called para virtualization, or um, different other term. So I think I'm gonna show you one of the implementation of the virtualization called VMware, which is one of the most popular virtualization kind of concept. Um, Continue on the benefits of virtualization. Okay, virtual machine system, it give you a perfect vehicle for operating system research and development, where it give you a complete kind of separate virtual resource or infrastructure, so that you can doing something with that without interfere to other system. So virtual machine concept provide a complete protection. One virtual machine that has some problem would get isolated, would not impact to other machine. In the past, virtual machine or virtualization, it kind of quite difficult to implement, and also it imposed a lot more overhead, because imagine that if you have two virtual machines that run two different operating systems, and if the hardware uh, is the same but also has slightly different kind of API. So you have to have a layer that translate the differences between those API or those requests. Okay, but nowadays modern CPU provide virtualization technology built into CPU, such as Intel has Intel VT, and then AMD processor has AMD V code name that support virtualization on the hardware. So therefore, implementation of this virtual machine concept is much easier than in the past and less overhead because it support at the hardware layers. Um, and why don't we do this? I think before we continue on, initially I thought that I will complete the virtualization lecture before I take the break. But let me take a break because my clock right now is around 9 a.m. So I think we have gone over around 1 hour. I think it's quite long. Take 3 minutes to 5 minute break. Okay. So I will resume lecture around 9:03 or 9:05 my time, which is I think we have lag time around 1 minute. Okay, so I'll be right back. Okay, guys, take a break and get some fresh air, and I will read any comment if you guys have any comment or you guys uh, are still awake or not. Okay, all right, so we'll get back in 5 minutes.
Walking down the street, I saw you in the zone. Only a month we've been apart. You look happier. So you walk inside a bar. You said something to make you laugh. I saw that both your smiles were twice as wide as ours. Yeah, you look happier. Ain't nobody hurt you like I hurt you. Ain't nobody love you like I do. Promise that I will not take it personal.
All right, guys. I think let's resume our discussion on the virtualization. So I think now I'm gonna show you a little more detail on VMware architecture. But again, I don't expect you to remember all these detail, but I just want to highlight a few things to you. So if you take a look at this diagram on VMware architecture, it look similar to those layer kind of architecture. Underneath it, you have the hardware layer here, and then on the top of this hardware layer, notice that you have host OS or host operating system. And in this case, it's just example that is running Linux. But in fact, the host OS could be Windows. So VMware support a few others operating system. Okay, and with this host OS, okay, is a the main operating system that running on the hardware before you spin up hypervisor or virtualization layers. Okay, so this host OS in fact is just like a barebone OS underlie that allow you to start managing all these virtual machine. And then on the top of host OS, okay, in fact, the host OS, you can run the typical whatever application because this is just standard operating system. And then on the top of host OS, then you have hypervisor or virtualization layers, okay, that you can create virtual machine. Okay, so this is one virtual machine, two virtual machine, and then this is three virtual machine. Okay, on this example showing you each of these virtual machine run different operating system like but notice that the operating system that run within virtual machine is called guest OS. Okay, so I want you to make distinction between host OS and guest OS. Okay, where host OS is used to manage all these virtual machine or virtualization kind of tools. Okay, so hypervisor or VMM that I referred previously, virtual machine monitor, okay, which you can think about is an operating system or virtual machine, okay, running on host OS. And then you can start managing multiple virtual machine by spinning up, okay, virtual machine that you can get a logical or an illusion of a machine or hardware, okay, or virtual machine that you may deploy different guest OS. Okay, so guest OS is running on those virtual machine, but host OS is operating system that used to manage or run virtualization tools. Okay, and from virtual machine you may have different OS, like you can run Linux, you can run Windows NT, you can run Windows XP, which is two different operating systems. So this is the concept or the high level of VMware architecture. But if we deep dive into VMware architecture or modules, that how VMware manage various things, you know, you can start seeing that VMware has various tools such as vCenter Server here, vSphere Client, and then Web Client and Terminal. And then in this case, the vCenter Server, it runs set up uh, modules. You know, I think if you want to deep dive and look into VMware architecture, there is a module that help manage network, that help manage virtual machine, that help manage the storage. Okay, and then you know all these modules may run on the top of enterprise server, so you may have various server group 1, group 2, group 3. If you hear the term called enterprise or private cloud or enterprise private cloud, okay, VMware has been used a whole lot in most data center nowadays, and most application that running nowadays mostly running on the top of virtual machine, not a barebone, because it's easier to manage, except just a few organizations that they have not migrate to this virtual machine concept. Okay, this is also another diagram, and you can see that underneath it you have a set of a storage or hardware storage that VMware also have the module to manage cloud storage. Okay, for the organization. Okay, and one of the popular integration between VMware and OpenStack. Okay, VMware is used mostly to manage virtual machine within a single server. But then OpenStack is also an open source a set of tools that help manage cloud infrastructure. Okay, so basic OpenStack framework consists of the dashboard, which is just like a panel that you have 4 or 5 major functionalities such as Neutron, Nova, Cinder, Glance, and Swift. Don't worry about this name, but I think uh, I'll speak this a few times because, by the way, if you are VMware and OpenStack certified, okay, you will make a lot of money. I think it's highly demand and not a whole lot of people has this skill set. So in fact, a lot of corporation or enterprise data center using this combination of VMware and OpenStack. So in this case, if some of you guys would like to pick this private cloud or deep dive into something similar to VMware and OpenStack as your term presentation, please do so. But as you see that underneath it, okay, this is OpenStack kind of um, modules, okay, that's sitting on the top of VMware setup tools, okay, VMware vSphere that it allows, the system admin to create compute, which is virtual machine, a virtual storage, and virtual network. And then on the top, you can use Neutron to uh, bundle together multiple virtual network and create or form a private cloud network, or Nova, which is compute node or virtual machine that it use vSphere as a driver to create virtual machine, and Cinder, and then Grants using to create or manage storage, okay, and then Swift also the storage, and Keystone used to manage security or authentication. Okay, again, don't worry to remember all this, but I mean, if you take a look at this diagram, you should understand, the how this thing work in the high level. In fact, when I first time when I take a look at this, it just completely makes sense to me. But I think, granted that you have some good background in terms of how this thing work. Okay, again, this is also another slide uh, of VMware integration. Okay, and so don't worry, just another diagram that specifically integrate with certain network like the Cisco network on the bottom. Okay, um, another operating system feature. Okay, I mean, most of you guys probably have program in Java and know Java virtual machine or JVM. JVM can think of as a tiny operating system, so it has a total inclusive of the system that you can run Java application. um, and in that case, you have a lot, and it's also hardware agnostic. Okay, so as long as you have JVM that run anywhere, then you can load any Java, whatever bytecode or Java program to run on most of system that has JVM deployed. Okay, so the basic architecture of this JVM or Java virtual machine is that you have a Java runtime, okay, on the middle kind of box, okay, that's sitting on the top of host system. A host system could be any of the hardware, but in fact, most Java or JVM is run on the top of operating system like Windows, Linux, or something. So it just give you another perspective that you have kind of tiny OS running on the top of OS as one app, but it has its own complete functionality that help you to manage activities there. Okay, and then you can load your program through this class loader, and then other library I mean, through the Java API, okay, that you can include into your program and run, and Java interpreter will interpret your bytecode and execute your program on this virtual machine. Now let's switch gear onto the aspect of when you have a brand new computer and you want to install new operating system. Various system, for example, in this Windows kind of environment, some of you guys may have very warrior machine like 16 gigabyte or 32 gigabyte memory. You have a very capable graphic card. The GPU is, or the CPU is top of the line like i7 or i9, versus another person may have, just simple notebook that may have 2 gigabyte RAM, and then maybe i3 kind of processor, or even Atom processor, okay, with small hard drive. Okay, so various system or environment may have various configuration, but then in order for operating system to run or deploy and optimize, take advantage of that specific environment, it must understand or knowing the configuration. Okay, so most modern operating system has ability to gather system information. That program, in generic term called system program, okay, that obtain information concerning about specific hardware configuration, so that when the system boot up, okay, then it make use of or allocate resource appropriately. Because if an operating system will manage 32 gigabyte RAM versus only 2 gigabyte RAM, the same similar policy or mechanism may not be able to provide a efficient way to manage. The same program may have to recognize which one has more or less, so that it can allocate resource appropriately. So most modern operating system, I mean, during install the new operating system on the hardware, okay, then it has a system program called system, okay, that will obtain specific information with respect to the hardware, and then gather those information and work together with a bootstrap program, okay, in a way that bootstrap program normally store in the ROM or read-only memory, or the firmware, sometimes we call firmware, that enable our ability to locate the kernel or the operating system, load it in memory, and then start the execution. While loading up, then it has to consult with a specific system configuration, so that it know how to optimize and operate and do the resource allocation. Okay, so the mechanism of to install operating system, the new operating system will require session in terms of booting or start up whatever your system require bootstrap loader or bootstrap program, okay, which normally store in ROM or read only memory, okay, which another term called firmware. I hope that, I think when you take architecture, or if you're gonna take architecture, you have to make distinction between RAM and ROM. ROM is normally, I mean, the firmware or the hardware code would store in ROM, but the RAM is a random access memory. It would be active after the system boot up. Okay, so in fact, operating system will make use of RAM after operating system boot up, and then start allocate memory for application to run, or load the kernel to run on those. Okay, so I think once you turn off, the code of ROM still there, but anything that in the RAM will be disappear. Okay. Yes, Justin, BIOS is mostly on the booting or bootstrapping program, but some implementation BIOS also work together with the sysgen. Okay, so the sysgen is part of whatever the BIOS or the code that gather the the system information. So I think let me repeat the question. Justin just typed a question asking that would BIOS be example of sysgen? Well, yes, but then part of the BIOS would be part of the sysgen because of sysgen is a program to gather system information. Okay, so that the during the booting it used those hardware information to manage a resource effectively. But then BIOS also include booting or bootstrap program as well. So BIOS is much more than the system. System is just one of the program in BIOS. That's the question. That's the answer. Um, so if it's not clear, please type or ask again. Or I mean, some of you guys, I encourage you to connect with me on Skype. We can do video call. Okay. All right. So I hope here is the diagram showing how the booting work. Okay. So you can think about, I mean, to boot your computer just like to start the car. I think you have to know how to insert, I mean, the key to whatever the key start, or if you have a whatever the modern car, you have button to push to start. So in fact, similarly to computer, I mean, when you hit I mean, to start, then computer, PC, when it turn on, then the BIOS will initialize the hardware and check all those system configuration that gathered by sysgen, okay, and make sure that they all correct and work well, okay, because if the hard drive previously you record that you have 1 terabyte but it does not exist anymore, you pull it out or it crash, then the system cannot boot, right? So in that case it has to validate and check the sanity of all those hardware that gather. So mostly sysgen just run once when you install initially install operating system, but when you reboot or boot your system, then whenever you turn your computer on, then the BIOS will kick start the bootstrap or the booting sector, and then it start validate and check, and after that the BIOS will call master boot record, okay, that is start at this 0. So this 0 is just a default main disk, okay, that store a main record boot, okay. Then main record boot then load the code from the boot sector that or of the active partition, okay, and then the active partition then in turn execute the bootloader, which is the boot sector located where the file system is and where the operating system or the kernel locate, and then load the program and kickstart, okay. And by the way, if you guys are interested in booting mechanism, there are a multi-boot mechanism like grub or lilo or a few others. So instead of you have a one boot record or whatever the one kernel image, okay, multiple boot mechanism, you may have a multiple operating system that in between or among this process. So instead of you have one master boot record, you may have a table lookup so that it provides choices of which operating system you want to execute, and this could be the term presentation that if some of you guys would like to take as or deep dive and learn more, okay, booting mechanism or multiple boot mechanism and tools, okay, would be the good topic. But basically this is a process in which how your computer get boot and then ready to be used, okay. So now little more detail on system boot, okay. Operating system must be made available to the hardware so that it can start the kernel. So there is a small piece of code called bootstrap loader that it's stored in BIOS. BIOS is basic input and output system, okay, which is in a sense it's just a firmware that store on whatever the ROM or EEPROM, read only memory, okay. And this bootstrap loader has ability to locate the kernel and load it in memory and start, okay. Sometimes you may have a two-step process, okay, where the boot block, okay, either have a fixed location or you may have a table lookup, so that you can have multiple choice of operating system that you want to load, okay, because sometimes I'm not sure any of you guys have played with a multiple boot or not, or multiple boot mechanism, okay. If you Google the term multiple boot and then use the term grub, GRUB, okay, is a one of the tools that enable this multiple boot record. In a sense, you can think about you have table that lists what are available operating system that you install on your hard drive and which of the boot record that you want to point to, which kernel that you want to execute and get started and then be ready to be used, okay. So basically the idea is when your system is power on, then the execution start at the fixed memory location called MBR, and that is the firmware that used to hold the initial boot code will load OS into the RAM, initialize, and then make everything ready to be used after it validate, I mean the hardware sanity, okay. So this diagram showing how the OS get work by you start off, I mean by bootstrap program at the ROM, which is the code is just permanent there, okay. And then it start reading the OS or the kernel from a known location on the disk storage, okay. And then after that it load the kernel, okay, to run on the main memory. So in this main memory, okay, it store on the RAM, which is a volatile memory. So RAM will be active after the system is boot up, okay. And then after that it start initialize and then get the system ready to be used, okay. So this is the diagram show a quick way how your system get boot up, okay. I think so that is the boot mechanism, okay. Now I think last 20 minutes I want to get into a hardware protection, okay. So basically there are a few hardware protection that work together with operating system in order to protect certain system resources so that the user can intentionally or unintentionally do some harmful to our system, okay. So we're going to talk about dual mode operation, which is a hardware mode bit, okay, that implement in the hardware that help switching between user mode and kernel mode, okay. And then we're going to talk about how I/O get protected. In fact, it make use of the dual mode operation using system call type of mechanism to do I/O protection. And then we're going to talk about memory protection, and last but not least we're going to talk about CPU protection, okay. So let's get started on the hardware protection that work hand in hand or collaborate with operating system. Now the dual mode operation, okay, provide this type of mechanism provide at the hardware level. So there is hardware operation or we call mode bits, okay, that help differentiate between user mode or kernel mode, okay. So in order to share system resources, devices, operating system need to ensure that the incorrect program cannot cause our program to execute incorrectly, or some program may not be able to directly access to those system resources, okay. So with that, as I mentioned, operating system introduced a user mode and kernel mode by implement mode bit, which is implement in the hardware. Why it's implement in the hardware? Because in that case, it helps switching from this mode quickly. If it's implement in the software or system program, it has more overhead because as you know that the program will have to load into memory and then start execute. But then if you do at the hardware level, it's just one instruction. You can flip from mode bit from user mode to kernel mode. Let me just remind you on what user mode and monitor mode. I think I mentioned this in CSC 222 when during the chapter that we talk about system call. The user mode is any activity or execution is done on behalf of user. So in that case, all the instruction that execute at the user mode, it run at the CPU speed. Okay, so there's no overhead, extra overhead on the top of this user mode. However, in the monitor mode or kernel mode, okay, or system mode, all execution is done on behalf of operating system. Why do we need to separate between user mode and kernel mode? Because the user may execute a normal code or normal instruction, which perfectly fine to execution at the whatever the system speed. Okay, it go fast as CPU can go. But then when the user application want to execute certain share resources or system resources, in that case, it's not a good idea that we let the user directly access to those system resources. What if the user has some ill intention, okay, would not release the usage of those, then all the user cannot use it. So therefore, it imposed the monitor mode in which on any privileged instruction or the system resources that the user application or the user want to access. In that case, operating system will switch from user to kernel mode or to monitor mode, and then put user process into suspended or into sleep mode, okay, and then transfer the control so that the kernel or operating system will execute those privileged instructions on behalf of that user application while the user is in the sleep mode. And then when the previous instruction or the system call is complete, then it will flip the mode back from user kernel mode back to user mode and wake up the process, transfer the control back. Okay, so this mechanism is imposed overhead, but then it provides a more secure way to access and execute the system resources. That is the main idea how this system call work and how the hardware work together with operating system make use of this mode bit, which is the hardware level protection. So the diagram is showing, flipping between a monitor or kernel mode to user mode, okay, where, if the monitor mode, the bit mode will set to 0, and then if in that case, operating system would take over and execute system call on behalf of user, versus when it flip back to user mode, then the user application can execute normal instruction at normal speed. Okay, so when is this mode bit, okay, will be flip or the dual mode will take in action whenever there's some interrupt, such as when the time expire on a process that execute on CPU but has not complete the task, but the time allocated is expired, then it will get interrupt so that it will get suspended and then put back into job queue again. Or when the user call system call, okay, or maybe when there's a fault occur during hardware the switch, okay. So all these event, okay, will cause the flipping between the mode bit from 0 to 1. Primary mechanism of this bit mode or the working of the dual mode operation is system call operation. As this diagram shows, it's flipping between user mode and kernel mode. Okay. Now this diagram also shows the schematic. Okay. On the top, you can view or think of as user application. When the user execute whatever normal instruction, it will execute at the user mode, okay, which is mode bit 1 made, then it will trap and the mode bit will flip from 1 to 0, okay, and then the user process will get suspend, and then the transfer will control or switch to kernel, and then the kernel will execute system call on behalf of the user, okay, and when the system call is complete, then it flip back from mode bit 0 to 1, and then wake up the user process, and then transfer the control back, okay. So I think this diagram I have, if you guys are in 222 with me, I have explained to you multiple times, okay, but if not, for someone who has not taken 222 with me, I think this is how the system call is done, and using dual mode operation or mode bit in order to ensure that those privileged instructions can be executed under total control of the kernel. Any question? Also, during the time in which the user process gets suspended, okay, process status must be saved into a data structure called PCB. As you see that PCB 0 and PCB 1. We're going to talk about this data structure in next chapter, which is chapter 3, process management. PCB stands for process control block, which is a data structure that represents process information such as process ID, process status, PC program counter, setup register, and a few other process related information. So in order to put the process into sleep or suspend the process, operating system must remember the information pertaining to that process. So therefore, it saves the software state of that process, okay, into given PCB. If the process 0, then it will save into PCB 0. And then in the case that we will switch another process to execute, then you have to reload the process state from PCB onto that given process, like process 1. This is PCB 1. And then you can start or resume execution of that process. So I think this diagram showing you the schematic that represent how multiple process get executed and switching, CPU scheduling, switching from application 1 to application 2 to application 3, or when a process makes system call or get interrupt, then you're going to see the action in which operating system performs save or reload or restore, okay. We're going to discuss this diagram multiple times because it's quite important, okay, in this class. Now, I think we will mention about this a little more in detail in chapter 3. As I mentioned, the PCB is a major data structure that represents each process. Okay, so you have process ID, process state, program counter, setup register, and whatnot. So don't worry about this point. I just want to kind of register this idea in your head before we get into process management. Important information, I think multiple times when you listen to, I think it's gonna just get to yourself naturally, okay? Now, switch gear. So I think the first protection is dual mode operation or use mode bit in order to flip between user and kernel mode, okay? Now, when we talk about I/O protection, all I/O, okay, instruction are privileged instruction considered as system resources, okay. So therefore, we must not have user gain the control, okay. So in this case, we use this dual mode or wrap around all I/O instruction with a system call, okay. So therefore, it will make use of dual mode operation and switch between user and monitor mode, okay, in order to allow user to access those I/O instruction, okay. So in the sense that the I/O protection is make use of the previous mechanism that we discussed, which is dual operation, okay. Now this is the diagram that's showing how the system call perform I/O, okay. First, when the user call the system call, then it would trap to monitor mode. So it will flip from mode bit from 1 to 0, okay? And then the operating system would take control. then it will look up which system call number. Remember, each system call, when we install or when the system get installed, the new system call, the new device, it will register that system call to the kernel, in which it has a unique ID or unique number associated with each system call pertaining to that given device. Okay, you're gonna hear the term major number and minor number. um, I think we'll talk about this later on. Okay, so I think some of you guys who take 222 with me, I have shown you, this concept on major number and minor number. So in fact, major number is represent a type of system call. But then some system call or some device, you may have multiple copy of those devices. For example, one system you may have the same hard drive, two copy of them. So in that case, each of the instance of those hard drive, you have hard drive type, which is represented by major number, and minor number is represent those instance of each of the type. Okay, so now once the system is trapped and then switch to monitor mode, then it start perform the I/O by operating system. Okay, and then after the completion, then it will return to the user and then flip the mode back. So I think in the sense that I/O instruction, it use dual mode operation in terms of protect I/O operation, which is previous instruction. Now, in terms of memory protection, uh, as you see that the modern operating system, you may have a various application running simultaneously, and then each some system you may have multiple user logging into the same system. So in that case, you have a mixture of various processes that may belong to multiple users. So therefore, it's not. I think it's always a good idea to protect the memory. When we say protect memory, protect the memory in which that operating system are already allocated, the memory that belong to task or application or given user, because within the task, within the process, within the application, you may have a important or private information there. So if you allow other process to interfere or to mix, the uses of those memory, it's gonna create some chaotic. So therefore, once the memory get allocated for each process, then the scope of those memory would be only known and can be accessed for that given process only, not to any other process. So therefore, operating system must provide memory protection mechanism, okay, in which it would not allow other memory to kind of overlap, to interfere. Okay, so the basic mechanism that operating system use to perform memory protection, it also make use of the hardware aspect, which has a set of register. The first register called base register. The second register called limit register. Base register hold the lower bound of the memory. So if the memory get allocated for given process, you're gonna have to have a starting memory address, okay, which is recorded by register, base register, and then you have limit register that define the range in which how large or what is the maximum address that given process can access. So in that case, a given process, before it access any memory, it will check against the base register. If the address in which that process want to access is greater than base register, then it potentially okay or candidate to be valid. And then it will also check with limit register to see whether it try to access beyond whatever the scope of this given memory process or not. Otherwise, if it does, then it gonna trap and then report error. Some of you guys may have seen, if you run the program, you've seen segmentation fault. Most segmentation fault is created by when you try to use pointer that try to access to memory location that does not exist to this given process. Okay, so this diagram showing how the setup register based or limit register, okay, being used to do memory protection. So therefore, when you see, I previously showed you the PCB, okay, which is this diagram. You see register or setup register, two of register base or limit, okay, it's stored here. So each of the process will have their own base and limit register, okay, in a way that it would check against any time when it try to perform memory access. So if I ask you a quick question, every time when you want to do memory operation, at least how many instruction, okay, that would require in order to perform memory access, one memory access instruction? At least three, right? First one is, the operation in which you will compare the address against base register. That's one instruction. The second instruction is you're gonna compare that given address whether it go beyond that limit register or not. If it's valid or fall within that memory range, then you can perform memory access. So therefore, it requires three instructions to against comparison against those base register and limit register, and then last but not least is the actual memory access. Okay, so I think that's an idea, and this is diagram or the flow chart showing how you use memory protection in terms of protect memory. Okay, from your application running, it generates the address, then you compare with base register first. If it greater than or equal to, then yes, then you check that address based against the limit or the upper bound. If it fall within that range, then you allow the access here. So this is the way you want to access or to perform memory protection, or operating system use this mechanism to perform memory protection. Okay, um, with this idea, I think you have seen that we use bit mode, okay, and then base and limit register, okay, as a mechanism to do hardware protection, okay. Last but not least, type of protection that I'm gonna discuss before I will conclude today's lecture is CPU protection. Why do we need to protect CPU? Because application or system process will execute on CPU. So in fact, to do CPU protection, the timer, which is a previous instruction, okay, will be imposed. That means you can kind of define elapsed time for given process to execute. If it cannot complete within this allocated time, then it will get interrupt, and so the timer will interrupt that process and then preempt the process, go back to the process queue. Okay, so timer, okay, is a mechanism, okay, using the interrupt computer to specify the period in which operating system will maintain the total control. Okay, timer also commonly used in the time sharing and multitasking, okay, in order to ensure that we can apply whatever the CPU scheduling in more fair fashion, especially round robin. I think when we discuss on chapter 5, when we talk about CPU scheduling, especially round robin, when we define time quantum, those are the mechanism that implement using timer. Okay, so load timer operation is privileged instruction, so therefore you must protect, never mess up with the system timer at all. Okay, because otherwise you're gonna mess up the CPU scheduling mechanism. Okay, I think I'm gonna complete the lecture today at this point. The rest I would ask you to go over, various operating system implementation or the architecture that I already gone through. So I'm gonna quickly flip through, the Unix or Linux type of architecture that has two different perspectives. The first one we show the functionality or whatever the services or feature, and second one show more layer, more subsystem type of architecture. So read through I mean, try to gain some idea how this layer approach works, okay, and the subsystem, and then you can see layer to layer, hardware to hardware control, and then in between kernel, and then we have Mac OS, Android, iOS, Windows. Basically, this is end of chapter 2. Okay. Um, I think I will hang on. I know that there's a few delay here. If you are typing, you have any question, so please type to the chat. Whatever the live chat session on this YouTube live. I will try to answer all the question. But otherwise, if you guys have any question, please feel free to contact me. I'm still available every day from 1:30 to 3:30 or otherwise anytime. Okay. Next time when we come back, I will talk more. I will start off with the first programming assignment. Okay. Um, Even though the due date is gonna be around right before the final week, even though we don't have final, but we're gonna have multiple quiz. Okay, so I want to get you early start on significant programming assignment, which is the tech shell that I want you to extend a few more features there. Okay, for someone who has no experience on whatever the tech shell, I will give you some whatever the kickstart or some sample code that you can use it. Okay, in order for you to start the assignment. So I think in fact I give you almost 2 weeks. Okay, so I think roughly, if I'm not mistaken, I target the due date of the textual programming assignment is May 12, but I would encourage you to start as early as possible. Otherwise, if you guys have no question, I think we've gone all over the time now. Please stay inside. If you have no very crucial thing to go outside, don't go. Okay, hang on. I think to in order to win against this virus is not to spread the virus. Okay, so and that I think please stay safe, and any question you can send email or you can do Skype with me. Okay, so I'll see you this coming Thursday. Okay, and we're gonna start off with the textual assignment. All right, guys, stay safe and have a good day. Bye bye now.